Hi, we're going to be looking at parallel and perpendicular lines today. So the first thing we need to talk about is what do we know about parallel lines? So what a parallel line is when you have two lines that are the same distance apart for their entire lengths, that is what is called parallel. So what does that mean? So I want you to think about where might you see parallel lines. Some of you might think about streets. Sometimes if you're on an interstate, those two sides that are going in opposite directions are usually parallel to one another. They're the same distance apart for their entire lengths, so you could think parallel. You can also think about railroad tracks. So let's look at this. In this first diagram, well, it says which two line segments below are parallel and how do you know? Well, if you look at these line segments, we have line segment A, B, and we have line segment C, D. Over here we have line segment E, F, and G, H. If you look at line segment A, B, and C, D, those two line segments are parallel because they are the same distance apart, and you can tell that on this graph paper because you can count the squares. So we have 1, 2, 3, 4 squares apart all the way down the length of the line. They're never going to get any closer together. They're never going to touch each other. However, if you look at these two line segments, EF and GH, they're 1, 2, 3, 4 squares apart on this end, but then only 3 squares apart on this end, telling us that those are not parallel because they are not the same distance apart all the way across. And if I extended this line and this line, eventually they would cross each other, so therefore they cannot be parallel. So parallel line segments do not have to be directly opposite each other or the same length. If the lines that they are part of are parallel, then the line segment will also be parallel. So what that means is even though A, B, and C, D are not the same length, they are on lines that are parallel each other. So therefore those line segments, even though the line segments are different lengths, they are still parallel. So the line segment here, JK, is parallel to line ST, and it's also parallel to segment TU. Even though JK is over here and TU is over here, it is still part of this line that is parallel, so those line segments are still parallel to each other. So you can then identify some other line segments that are also parallel. So then we have to talk about perpendicular lines. So a perpendicular line is going to make a right angle when they cross each other. So this yellow line is perpendicular to this purple line. So if you look here, you can tell these are these are right angles because they form that perfect square like we talked about identifying those a few weeks ago in class. So that is going to be a perpendicular set of lines. Now something to know about perpendicular lines is that they do not have to be vertical or horizontal, meaning they don't have to be straight up and down or straight across. These lines here are also perpendicular to each other. They still create a right angle that you can see. It's a little bit harder to see because it's not perfectly around one of those squares, but if you look at this, you could still use, I know we talked about using the corner test using a piece of paper. If you stick that corner of your piece of paper in there, you can see that it forms a right angle. So therefore, these are still perpendicular lines to each other. Another thing you need to know about perpendicular lines are they do not need to intersect one another. So these line segments can be perpendicular even if they do not actually cross at their right angle. But if I extended them, as you can see these dotted lines are showing here, they would eventually cross and form that right angle. So this line segment can still be perpendicular to this line segment even though when they're drawn here they don't cross, but eventually if I extended both of their lines they would cross, making those perpendicular. So to review, we have talked about parallel and perpendicular. So our parallel lines are going to always be the same distance apart and go on in each direction, and they would never cross each other. So here we could say that segment AB is parallel to segment DE. And then we could also name others within this. Another way we can identify parallel and perpendicular are in polygons. So if we're looking here, you can then use these labels to do the same thing. So we could say that side AD is parallel to side BC because they are the same distance apart and they're going to go right along the sides of each other. We could also say that line IJ is parallel to LK because again they're the same distance apart and they would extend in both directions. Now if we look at this last shape, do you see any parallel sides? Well, we have sides that are opposite each other, but if I look at these and I extended these out, eventually they would cross each other. So these lines, these sides cannot be considered parallel. They would cross each other eventually. And again, if I looked at E, H, and F, G, it would be the same thing. If I continued these out further, they would eventually cross each other and they would not stay the same distance apart. So those are also not parallel. So that's how you can identify parallel lines in a shape. So you could also look and see, well, do we have any perpendicular lines in a shape? So again, those ones that cross, just because they cross, those are called intersecting lines. That is like an intersection. Those are not necessarily perpendicular though, because they might cross each other but not at a right angle. So if I wanted to identify my perpendicular lines within these shapes, well, I could look here and say that IJ and IL or LI, these two would be perpendicular because when they cross each other, they're going to form this right angle. Okay, so that's a way you can look at those different angles within a shape. So here's another thing that sometimes you see these little arrows showing parallel lines. So usually if you have more than one set of parallel lines in a figure, this is what we use. So they use these little arrows. So this means that the one arrow, this side, is parallel to the other one arrow. Well, in this figure, there are two sets of parallel sides. So they use the two arrows to show that the two arrows on each side are parallel to each other in that figure. So that is another way you will sometimes see those. So you guys can move on and look at the practice page that you have in your assignments and go through. You can just work those out on a sheet of paper. Don't feel like you need to print anything. You have the shapes are also attached that you can just draw in if you'd like to see which ones have parallel sides, which ones have perpendicular sides, and which ones have both parallel and perpendicular sides. I also attached the answer keys, so after you have thought through this, you can check your answers with the answer key and then do the IXL. I will be checking for completion of the IXL to show that you understood this lesson today. I hope you guys have a great day, and I will see you soon. Thank you.